all of you. Today I came with another circuit theorem which is related to electronics. That is nothing but Thevenen's theorem. We already discussed one more theorem, that is nothing but superposition theorem, in the before video. In this video we are discussing about the Thevenen's theorem, which is also called as voltage theorem. Coming to the statement, any active linear and bilateral network can be replaced by a single voltage source with series resistance. That is, if any network, if you consist of any type of resistances and any type of voltage sources, it will be replaced by a single voltage source and also the single resistance. This is nothing but the Thevenen's equivalent circuit. This is normal circuit which consists of the resistances and also the voltage sources. This circuit will consist of the same current when compared to Thevenen's equivalent circuit. This is the theorem statement. Coming to the proof, first we have to take any type of circuit, which I have taken here the circuit for resistance, say R1, R2, R3 and RL with a single voltage source V, and I1, IL are the mesh currents. This is one mesh and this is the second mesh. First mesh current is I1 and the second mesh current is IL. Let I1, I2 are the mesh currents. That is the figure. That is the circuit I have considered here. Here, by applying KVL to the AB DA, V minus I1 R1 minus R2 into I1 minus IL. By solving this equation, we get V is equal to I1 into R1 plus R2 minus IL R2 is equal to IL R2. This is the first equation. Next, mesh 2, that is nothing but B, C, D, B. From this we are having R2 resistance and R3 resistance and also the RL resistance, and R2 is related to I1 and IL. How we can write the equation? That is nothing but 0 minus R2 into for which mesh we are writing? For this mesh, na? So first of all we are taking IL, after that we are taking the I1, that is 0 minus IL RL minus I2 R3 minus IL RL plus I1 R2 is equal to 0. That is, by solving this, 0 is equal to IL combination R2 plus R3 plus RL minus I1 R2. This is going to that side, minus become plus, plus becomes minus. This will become the equation 2. Next, by applying Cramer's rule, we get V0 I1 IL R1 plus R2, I1 coefficients R1 plus R2 minus R2, IL coefficients minus R2, R2 plus R3 plus RL. From this we know that delta is equal to AD minus BC, that is R1 plus R2 into R2 plus R3 plus RL minus R2 square. Here minus into minus plus, na, so that is R2 into R2, R2 square. R1 R2 plus R1 R3 plus R1 RL plus R2 into R2, R2 square plus R2 R3 plus R2 RL minus R2 square. This R2 square going to be cancelled, because here we are having plus and here we are having the minus. We can write that R1 R2 plus R2 R3 plus R3 R1 as sigma R1 R2 plus RL coefficient R1 plus R2, that is R1 plus R2 into RL. Delta 1 is equal to, by replacing, that is V0 here, first column will be replaced by V0, second column will remains as same, minus R2 plus R3 plus RL. Delta 1 is equal to, we know that AD minus BC, AD V into R2 plus R3 plus RL minus BC means 0 into anything 0, that's why we are writing here delta 1 is equal to V into R2 plus R3 plus RL. Delta 2 is equal to, here we are replacing the second column with V0, that is R1 plus R2 minus R2 will be same, that is V0. Delta 2 is equal to R1 plus R2 into 0 minus VR2, na, minus, here also we are having minus into minus plus, that is nothing but VR2. So I1 is equal to delta 1 by delta. What is the delta 1 value? V into R2 plus R3 plus RL by delta sigma R1 R2 plus R1 plus R2 into RL. What is the I2 value? That is IL value, delta 2 by delta. What is the delta 2? V R2 by sigma R1 R2 plus RL into R1 plus R2. This is the circuit current which we have considered. Now we are solving the Thevenin's voltage and the Thevenin's resistance and also the total load current. Here estimate the load current according to the theorem procedure. First we have removed the load resistor temporarily, that is the load resistor temporarily, and estimate the open circuit voltage, which is nothing but the Thevenin's voltage. Open circuit voltage, which is nothing but the Thevenin's voltage. From this mesh, V into I1 R1 plus R2 minus IL R2 minus IL R2. This is the equation 3. And from this equation we are getting the, from this we can write minus R2 into IL minus I1 minus IL R3 minus V Thevenin's. So we are taking minus V Thevenin's is in the LHS side and taking the remaining terms into RHS side. That minus become plus, that is IL into R2 plus R3 minus I1 R2. This is the equation 4. Since there is no voltage source in the second mesh, then the current IL is equal to 0. In the open circuit, current is 0. So we are taking IL as in the IL as 0. That is third equation becomes V into I1 into R1 plus R2 because IL is equal to 0. And the fourth equation becomes V Thevenin's into, here minus V Thevenin's is there na, minus V Thevenin's, this term becomes 0 minus I1 R2 in this side. So minus is going to be cancelled. V Thevenin's is equal to I1 into R2. From this equation we get, by applying I1 is equal to V by R1 plus R2. By substituting this we get V Thevenin's is equal to V R2 by R1 plus R2. V Thevenin's is equal to V R2 by R1 plus R2. This will be taken as equation 5. Now we have to find out the R Thevenin's, that is nothing but the Thevenin's resistance. Remove the energy source V and estimate the open circuit resistance. Here the V, we are removing the voltage source first, only we are taking the resistance values, that is R1, R2, R3, that is R Thevenin's. Here R Thevenin's total resistance, R Thevenin's is equal to R1 parallel to R2 plus R3. These two are in parallel and this parallel combination is in series with the resistance R3. By solving this equation, that is R1 parallel to R2 plus R3, R Thevenin's is equal to R1 parallel to R2 means R1 R2 by R1 plus R2. Here I have solved, that is 1 by R, total resistance 1 by R is equal to 1 by R1 plus 1 by R2, 1 by R is equal to, here we are taking the LCM R1 R2, R1 plus R2, R, this is in reciprocal na, we are taking the R, R1 R2 by R1 plus R2. Here we are taken R1 R2 by R1 plus R2, R1 parallel to R2 means R1 R2 by R1 plus R2 plus R3. By taking the LCM R1 plus R2, R1 R2 plus R3 will be multiplied with this term, that is R3 R1 plus R3 R2. This will be become sigma R1 R2 because R1 R2 plus R2 R3 plus R3 R1 we can rewritten as sigma R1 R2 by R1 plus R2. This is the value of R Thevenin. Now we are making the circuit with V Thevenin's and R Thevenin's and find out the load current value. That is Thevenin's equivalent circuit by using 5 and 6. The equivalent diagram is V Thevenin's, R Thevenin's, RL, IL, load resistance and load current. We are finding the load current here by applying KVL. V Thevenin's is equal to, that is V Thevenin's is equal to IL into R Thevenin's plus RL, IL into R Thevenin's plus RL. From this equation we are having IL is equal to V Thevenin's divided by R Thevenin's plus RL. By using 5 and 6, that is 5, we are having the 5. What is the value of V Thevenin's? V R2 by R1 plus R2 divided by, what is the value of R Thevenin's? Sigma R1 R2 by R1 plus R2, and also here we are having the RL na, plus RL. By solving this equation we get, here take V R2 divided by sigma R1 R2 plus RL into R1 plus R2. This R1 plus R2, this R1 plus R2 will becomes cancelled. V R2 by sigma R1 R2 plus RL into R1 plus R2. This is the equation B. Here we are having the equation A. V R2 by sigma R1 R2 plus RL into R1 plus R2. Here also we get R2 by sigma R1 R2 plus RL into R1 plus R2. From this equation, from A is equal to B. Hence the theorem is proved. That is, we replaced the resistance value with Thevenin's resistance and the voltage value with Thevenin's voltage. We get the same load current when where we are get the basic circuit voltage, that is basic circuit current. IL is equal to VR2 by sigma R1 R2 plus RL into R1 plus R2. Okay ma, thank you. Please like, share and subscribe my channel. If you want more videos, please comment me in the comment section.